Welcome, everyone. My voice is very loud. It's good. I'm Manny. I'm an operations engineer at Behance. I've been with them for about a year. This is my coworker.
Hi, my name is Chris Fortier, as my card says. I'm a quality engineer on the Behance team. I've also been with Behance a little over a year. So, as the slide says, moving data centers is scary, make it less scary with Chef. About 6 months ago, we started this journey of trying to operate from our physical data center and rack space and moving to Amazon. And really we have just one big goal, is to share the story of what we did and some of the stuff we learned along the way. Also, we'd like to say thank you for showing up today. We're very humbled that you've taken your time to listen to us talk. So first off, the challenge. Here's a nice little chart from an online game. It was also referenced in a talk by Jamie Windsor last year, which is a great talk. This is for the online game, but a lot of people see this as the learning curve for Chef. It's also the learning curve for working in 2 different data centers, or 3 at the same time, because working in multiple locations is really, really hard. So one of the big secrets is that we didn't do it all at once. We didn't just say one day, we're going to turn on this data center and turn this one off. That would just not work out very well. So we did it in steps. So our stages were, we started in dev environments. So every developer we have gets a VM with a superset of all our applications that we're about to talk about. But we did everything with Chef first. That way we can have a controlled environment, we can learn Chef, figure out what's going on before we start rolling it anywhere else. We then moved to the QE environments. And we did all the QE environments in Amazon. That way we can learn Amazon, but also learn how Chef works with Amazon. Once we were stable with that, we said, okay, we get this. We get Chef, we get Amazon. Let's go full speed with it. We made the decision that all new applications, all new features for our site would be built in Amazon 100% with Chef, which is where we're at today. But then we have the pestering task of we have physical servers. So even with that, as we do upgrades, as we have new features come out, all of our physical servers get upgraded with Chef. And that's kind of the secret of how we've gone through so far. But before we get into some of the technical details, Manny, can you tell us about Behance?
So Behance is the leading online platform for showcasing and discovering creative work. We basically try to work with creatives, give them a way to get out there, to discover each other, to show up their work and what they've accomplished. We really want to empower the creative world to make ideas happen. We want you to be able to think of something, put it out there, get feedback, and take action on it. We have a huge community, and being able to keep that up and running and available to them is really important to us. We want to make sure that people are happy, that they feel good about sharing their work, and they can trust in us that when their work is out there, people are discovering them, they're being found. This entails a pretty complicated infrastructure. We have a lot of technologies. We have cloud servers talking to physical routers, talking to physical servers. We have a huge Mongo cluster. We have several different applications, some that are their own products, and some that actually feed the back end of the network. Each of these just talk to each other through an API, and it's a really nice architecture to deal with in general, but it does complicate things, especially with our physical and cloud mixture. We even have some scripts that help us have cloud servers basically authenticate back to a physical router and connect to the rest of the physical network. It gets interesting. The problem with having all these technologies is tying them all together and also figuring out where to start and what cookbooks to start with. We tried to find a common denominator for this and something that we could apply all our technologies to. We basically had a VM that did all this, and Chris is going to tell us about it.
So what is the bodega? The bodega is a central piece of work for us on our team. It is everything except the test kitchen sink. To give you a graphic of it, this is pretty much our bodega. For us, it's actually a virtual machine, but in that virtual machine, we run everything. We have CentOS, we have Apache, we have PHP, we have Gearman, we have like 4 or 5 databases, Mongo, MySQL, Elasticsearch, Amazon Dynamo, Local, and we even have Datadog running on it, so it can kick out some performance statistics to us. This is a pretty big undertaking for us, but what it gets us is every developer gets this bodega when they start, but it's the full superset of all of our applications. Every single thing, our Behance network, all the other properties we have. But what it gets us from the operations side and the testing side is all of this stuff is done with Chef, 100%. So this was kind of our path of, if we can get all of this to work in a VM with Chef, then we can be really confident to get it working in production. We use this for all of our dev environments. We use it for all of our QE environments. So you might be wondering of why the name Bodega. We are a New York-based team. We're in the middle of Soho. We wanted something that kind of reflected that. And so a bodega, it really is basically it's a small store with a little bit of everything. But if you look around long enough, you're going to find stuff that's been there for a couple of years, like old code. So let's talk a little history lesson. We call BC, which is before Chef. Before we had bodegas, before we had this concept, a year ago when I started, a new developer started. The developer sitting next to them would close their VM, hit the export button, put it on the file server. I got it, somebody mucking around with it, and it worked. As you can imagine, that's not a really scalable solution, so we figured out a better way. Our better way is Bash. We went from that to Bash scripts. That's a 40-line segment of one Bash script that calls 40 other Bash scripts just to get these things built out. That kind of tells you the architectural challenge that we had with all of this. It also created the blueprint for how we do it with Chef. A nice little slide here with that. How many people relate with this? Yeah, I've done some stuff I'm proud of, and the stuff I'm proud of is disgusting. You know, a lot of us have like old, really hacky stuff, and kind of the point of this is like, yeah, even on our team, we had some really old hacky stuff that we weren't really proud of, but it worked. But you know, we made it better. So let's talk the new way. Our new way is, I actually have another slide here of other terrible stuff to do. When we started running Chef, we did this. We did a Chef cookbook that pulled a Bash script down and ran the Bash script. Mo disapproves of this one terribly. So our new way is Chef. We have this one command. It pulls down a Bash script. All this Bash script does is configure Vagrant, gets all the stuff for Chef, the validation keys, tells it which server to hit. And it kicks off Vagrant, which then kicks off a Chef run. With this process now, today, a new developer can be up and running in half an hour with a full bodega ready to go with all of our applications. So we're going to talk about some of those details in a few minutes, but Manny, can you tell us why we moved?
So the day came, it was inevitable we had to move. We, up to this point, have actually worked with Rackspace for a very long time, and we had a great partnership with them. We grew a lot of our infrastructure with them. When we were acquired by Adobe, we realized that there's a lot of products we can integrate with, we can take advantage of the technologies they've built up, but this meant kind of moving to AWS, taking advantage of the AWS services they have, some of the mix-ins we can jump on, and make our product better. This meant a lot of the physical had to be cloudy. It's a big change, and it meant changing mentality too. We had to give up host names, we had to give up a lot of things that we had used as reliable sources of information, and had to develop new ideas. This also led to the idea of quality and operations working together. Chris, you want to tell us about that?
So let's talk about the CoOps team. New term, sounds suspiciously like another big buzzword in our industry, but it's really what happens when QE and operations gets together to work on something and realize that, hey, we have the same needs, we have the same stuff that we need to accomplish. This is one of the biggest changes to our whole process is that you have the silo of operations, you have a silo of QE. Well, QE had infrastructure, we had test infrastructure we needed to build, and we were hitting limits. We ran out of server space, we needed more stuff to use. Well, operations also had things they needed to get done. They have servers, they have bash scripts, they're moving to Chef. They need testing for it, they need quality control. And so then we get this CoOps team right there. If you look at it, there is about 80% overlap between our two teams on a day-to-day basis. Also, one of the notes of that is the bodega responsibility. So the bodega process we've had for about a year now. The responsibility kept swinging between operations and QE. At the time we made this change, it was really a QE responsibility, and it became a CoOps responsibility. Manny, can you talk a little bit about the team?
So the team ended up being about 7 people, which might be big for some companies, but the reality is for us, we couldn't give up any of our other responsibilities. We still had quality testing going on, operations was still dealing with issues left and right, and we were still integrating with Adobe, so that was more challenges. But we knew we had to move. So with every free second we had, we started working on cookbooks and started making the process easier and easier. And we realized to accomplish anything, we had to automate everything. It had to be as hands-off as possible. it also involves, as I said before, a mindset change. We couldn't rely on physical servers, and even some of the cloud options we had prior, we named them, we treated them as holy, and we kept them around as long as possible. And we had to let that go, and that was hard. And this is one of my favorite quotes because it is exactly what exemplified what we were doing. We wanted to give up the idea of caring for these things and just create servers, destroy servers, walk away from them, and not feel bad about it. And we wanted to be able to grow, and we saw that happening. Every integration with Adobe brought in more users and brought in more attention to Behance. So with all this growth, we had to accommodate and had to be able to react quickly. It was huge to be able to fire and forget servers, and to basically say, okay, we need tests to automate things, we need Jenkins to kick off things. We were no longer building infrastructure to test things, to rely on things. We were now scripting infrastructure and having infrastructure spin up when we needed it and get rid of it when we didn't need it. Some of the requirements that we actually had to make this move, we decided were knowledge of AWS. You got to know your new data center. You can't just jump into the deep end of the pool without thinking about it. We had the advantage of having time to migrate slowly. We knew our application. We knew that we could break it up into small pieces, and we dragged it out as long as possible. So we wanted to know AWS. We wanted to know Chef, how to pass information between nodes. How do you orchestrate things? How do nodes know about each other? What's a data bag? You know, it was all new things to us. And we knew that at the very least, the bodega, which covered all of our technologies, had to be fully automated with Chef. There had to be a separate cookbook for every item on there. That way we knew we had full coverage at the very least. What else did we learn, Chris?
So one of the things we learned as we merge the teams and start working together, everyone needs to sit together. If you look at our floor plan now, you have a DevOps person sitting next to QE, sits next to another DevOps, next to another QE. It really helps for all this collaboration, for the two teams to sit next to each other, you can overhear each other, and you also pick up knowledge. The quality engineer picks up infrastructure knowledge, and the operations people pick up quality engineering knowledge. But Manny, why did we choose Chef?
Because it's delightful.
Excuse me.
Chris?
Sure. So one of the things we started doing, and yeah, Chef is very delightful and awesome. We got really comfortable with the bodega concept. We had some pretty stable, we thought, cookbooks. So we decided, hey, let's dog food the cookbooks. We're going to have every single developer run Chef client every single day when they come to work. Because that seems like a pretty logical thing to do. And if you have every developer run Chef client every day, it's rainbows and unicorns, right, Manny?
Absolutely, every day, constantly, except when it's not. And what we discovered was that running things in development environments, people would break things. Weird things would happen. And that actually bubbled up to our production environments, and it was awesome. We had weird users that would show up, or we would have conflicts with like a system user and an actual user and their UID, GIDs, which we try to control. We had weird package issues. For some reason, someone would get a newer package than someone else, and we had to figure out why certain repos were doing that. And really small things, just remote sources. You pull from Git, you pull from remote files. You don't really know what to expect until you actually do that in that environment. And that was huge when we were running in dev and QE tiers. They would actually be in different places, and we would see random things breaking. And using Jenkins, using other tools, those came to light. So what did we learn? So we learned we need to control all the things. There's a lot of things, a lot of external dependencies. You have operating systems, you have packages, you have GitHub, you have all sorts of stuff that could break your Chef client run. And typically you assume Chef clients can be run automated, that you're not going to be there to fix it. So know your versions was one of the first things we had to learn. Like every single package, we had to know I need this specific version. We had to lock down all of our dependencies. We had to know every single dependency and make sure that only those ones were available. That kind of led us down to the point of having our own dedicated repo mirrors. So in each of the locations we operate in our office, in Amazon, in Rackspace, we keep dedicated repos and repo servers for all of our instances. So every time you need to run a Chef client, it knows, hey, I'm in Rackspace, I need this repo server, and it only knows which repos it has available to pull off of. It really helped us really stabilize all the Chef client runs. We ran into issues where CentOS released a new point version and broke everything. Everything just stopped working all of a sudden. So this is one of those nice little hacks to fix that. The repo servers are based on location.
So we'll talk about that in a second, but the instances do know where it's physically at to know the closest one. The other nice thing you get with that is you're only going across a data center. So your install times are really, really quick. So once we solved some of these things, we got things hammered down, we decided to dog food all the QE instances. This is a chart from Datadog, which we use to monitor and get stats on our infrastructure. Our QE infrastructure for our development code, so the PHP side and JavaScript side, it has a Jenkins master and one instance that we leave running full time. However, Jenkins has the EC2 plugin and can auto scale up to, I think we have it set to 100 instances. But you can see here that on this day, a couple of weeks ago, we were up to 30 instances at one time. Every single instance we spin up automatically runs a Chef client run. It's just baked into the process. It gets the instance. This is a really awesome thing because it helps kind of control cost, but it also helps for our cookbook testing. So Manny, our slide says that we are here to talk about working in multiple data centers. Do we have any hacks for that?
Yes, we actually did it. Surprise. This was actually really challenging, and the solution we came up with was really simple, but we wanted to be able to just say, you are here, and we're telling you are here, so expect to be here. And we came up with what ended up being 3 locations and putting those into environments. That basically let us predict the behavior of any node. We were telling the nodes how to behave, and it was better than waiting to see what the node thought it was in. So we came up with a namespace, BE. That was for all the holy attributes that we thought would only be added by tribunal, with everybody getting together, meeting, and voting in a majority that we would add a new attribute to this namespace. And they would be top level above every cookbook. And you couldn't create an environment or do anything outside of a cookbook without creating this BE namespace. So it was always there. So we ended up with three locations. It was our office, which is in Soho. It is AWS and Rackspace. Since we were telling the nodes how to behave, we could then predict in cookbooks during development time what we wanted from them. So we would just say, this is the repo server you want. This is the source you want. We now just had simple case statements, simple if statements. There was no weird, we weren't dealing with OHI plugins, we weren't dealing with complex structures. It was just do this when you see this. And it made our lives way easier. But on top of that, we were able to create test suites that simulated these behaviors. So we could make it pull from a certain location. We could force things. We could actually push different versions of PHP for different locations and see what would happen, just to see what repo servers it hit, what the end result was. It was actually a great experience being able to not only do it in production, but actually have tests run that thought they were in AWS or thought they were in our local office. And being able to test our local office was huge because we no longer had developers coming to us saying like, oh, this broke, and we would have to sit there for an hour dealing with their one dev box. And even then, now we just destroy their dev box and give them a new one. It's no longer a big issue. So on that note, what else did this give us?
Great, so we know how to work or we can tell Chef how to work in multiple locations, but what happens when you have different versions? You ever see this? Developer comes running over, hey, I need the new hotness. This latest thing came out. PHP 5.5, whatever, just came out. I have to have it today. I need this new fancy feature. I want to test it. I want to work on it. Typically, operations would say, well, maybe not. That's going to be really hard to do. But we actually found a really simple, what we think elegant way to do it so that we can say, yeah, we can make it happen. What we did is using attributes as a gatekeeper for Chef. Couple different screenshots here. It might be hard to read for you. I apologize for that. So what we do is we say, in this case, PHP. We have a default PHP 5.4 version that we're going to run everywhere. So we write in the bphp default attribute, that's our version. Simple enough. We always call the default recipe. If ever you need PHP, so you call bphp default, it will check, is this version, what version is set? If it's 5.5, call the bphp 5.5 recipe. Otherwise, just run default. The side on the right is the bphp attribute file, but what happens here, if you specify 5.5, the bphp 5.5 recipe gets called, and that defines everything for that. It has dependencies, it has everything special for 5.5 versus 5.4. It also reads in that attribute file. One note of this, if you're ever going to try this model, is Chef attributes, every single attribute file gets read in no matter what. So in that attribute file, you have to put this if block to check for that attribute. It is kind of hard to see. I apologize for that. So those two attributes right there, the B location and the PHP version, that gives us a ton of flexibility so that we can programmatically in, say, a role, define what this instance is going to be. Where is it going to live? If it doesn't need special versions, it creates a nice little abstraction layer to really figure out, okay, I am testing in Soho, or I am QE in Rackspace. Whatever it is, we can kind of control all of that through those two attributes alone. Manny, can you talk a little bit about our workflow?
So we ended up with a pretty complicated, well, I guess as complicated as anybody else's cookbook testing suite. But similar to the way any developer would work, we use pretty much every tool that's out there. It was interesting. We took advantage of testing because we wanted to make sure that nobody could make a mistake, nobody could make a change that wasn't caught by somebody else. We wanted to make it obvious, we wanted to make it automated, and we also wanted to make sure that there was peer reviews. If you wrote something, made a change, and we weren't checking it, there was a problem. We wanted to make sure everything was tested. It led to this workflow, and it's very similar to any developer workflow, really. So GitHub, work on stuff locally, make a pull request. We actually have something called Mergatron, and Mergatron will listen for pull requests. Any pull request, it'll merge master into your branch and run tests against that. That then shows up on GitHub in your pull requests. So when somebody else comes in to review it, they see tests have passed, and they see that they can see all the code that you've changed. So that means they can look to see, have you added tests for new features? Are these things totally overlooked? And we can deny your pull request if we want to, but it's visible. And we require that at least 2 other people on the ops team, QE team, the QE ops team, actually review your pull request before it's merged to master. Once it's merged to master, only Jenkins can actually push cookbooks to the server. So no one can override what you have. Every cookbook on the server gets frozen, and Jenkins is the only one with control. So if you want your changes on the server, you have to go through this flow. And the best part about this is that every test gets recommitted. Every test, whether it's in AWS, in Rackspace, whatever it is, it'll break locally, but you can run it locally. And I can test on my laptop. And I love that. And the best part about that is that any test that I write, anybody else can test on their laptop. And that's huge. And Chris actually has done that all over the place.
So I had a really interesting case. Little pro tip for you. I was flying on a flight from New York to San Francisco about 4 weeks ago, and I had surprisingly stable Wi-Fi on Virgin America. So I did what any sane person would do. I ran Chef, because that's what you do on an airplane. But running Chef at 30,000 feet on slow Wi-Fi, or slow Wi-Fi in that case, it shows you little inefficiencies in your cookbooks. It shows you things like, why am I downloading the same 20 megabyte tar file every single time I run Chef? This is really silly. I need to fix that. Just a little fun tip if you ever have that opportunity to do it, because you're going to find ways to cut off 10, 15, 20% of your cookbook runs right there. One of the things I do want to call out, though, as we're talking about this stuff here, Manny talked about all the testing stuff. And this goes back to our QE ops mindset and mentality. I'm the quality engineer. He's the DevOps engineer by title, at least. But he's the expert on all the testing. I can tell you the framework. I can tell you how to set it up. But this kind of shows the kind of that interplay between our teams, in that I can talk infrastructure, he can talk testing, and we can go back and forth. It's kind of a lot of what makes us the team we are. I will finish off on talking about test monitoring, though. We have 3 slides here, and all 3 of these actually rotate through a screen, sit right above us on the wall now. The one on the far left is Jenkins. So that's Jenkins wall display. Those are all of our cookbooks on master and all of the test status. So we have all that. We can see it. We can know what's going on. The one below that is Datadog, and it might be a little hard to see if you're in the farther back. Datadog is nice in that you can write your own custom stuff with it. So it's all in Python. There's a Jenkins API. There's the Datadog API. So we have a script here that pulls the Jenkins server every minute. It checks for the amount of cookbooks you have, what the status is, and kicks it to Datadog. So we also have this up on the screen to see, hey, here's the status of all of our stuff. Everything's working, everything's not. And the one big final test we do is a huge integration test, which is build a bodega. We actually have a Mac Pro sitting in the office. Its entire job is every single hour, it does the entire bodega build process, Vagrant to VirtualBox, a full Chef client run, It's an integration test. It tests that our office has network connectivity. It tests that GitHub works. It tests that our chef server works and isn't breaking. And that literally fills up a whole 55-inch screen to see if it's there. The other thing too is that if it breaks, we know, hey, the bodega broke, somebody needs to go fix it, and we can stop and get to it quickly. It's just a nice little hack that we have. So a little bit about our process. All the process. Code wins arguments. A lot of times we'd like to sit and discuss and debate, let's architect this whole process out. But in reality, a developer can spend an hour writing code and display that and say, hey, this code works. That's definitely one of the things we do. We do like our arguments, but typically the code wins. If you can prove that what you want to do works, then we use it. Other notes, chef is idempotent. Your cookbooks might not be, especially when we first started this journey. We'd write the cookbook and we'd say, let's get this to work in Amazon, and it did. And he ran it in Rackspace, and it broke all over the place. Definitely keep that in mind. Treat your servers as ephemeral. Granted, this is definitely more of the cloud concept, but if you use this as your default, then it makes working on VMs or working in physicals much easier. Like you learn to figure out the cases where things are going to break. Now, we did have a lot of issues with environments initially. Things breaking, this cookbook version X is here, version Y is there. Manny, how do we solve that?
So first off, we ended up putting all our attributes that were important in environments. We wanted to make sure that it was available everywhere and it was hands-off. Then we locked cookbook versions. We actually use Berkshelf. You take the Berks file and we apply it to the environment, and that guarantees that what was in testing is now in production. We know that they work together, they will always work together. When we want to upgrade, we then change the whole environment to make sure that our giant suite of cookbooks all still work together. And we're failing in dev, in QE. We're not actually making mistakes in production, and that's huge. We can now make changes in production and trust that they work. You want to finish this?
Yeah, let's bring it on home. Every tech presentation I've been to has a slide. The obligatory, of course, we're hiring, because everybody's hiring. It's so hard to find good people. And then, we're going to close it up with a thank you. Like I said, you have plenty of other options. It's humbling that you chose the time to come and talk to us or listen to us. We do have speaker hours. It's going to be in about 10 minutes, somewhere downstairs in the Marina room. I'm not quite sure where that is.
Yeah. And if you have any questions now, I think we have a few minutes.
So I got a pretty simple question. I come from a company that is pretty old school, and while we have cloud, we have a lot of physical too. So I was kind of wondering, you say that you use Amazon. Do you use that in production too, or is that only for your development environments?
No, we actually have portions of our main network in Amazon. Like I said before, we're pretty SOA in our architecture. So everything's API based. So anything that was API based that we could move to Amazon right now, we kind of did. And we have our main products now going across the web to Amazon.
Okay. All right, thank you.
Other questions?
This should be sort of easy, quick. How did you do it? First of all, you mentioned that you have to do two people do code review sign off.
Yes.
What's your mechanism and/or tool for that?
Trust?
Yeah. GitHub pull request. That's what we do it all. We use Slack internally, and we just have a DevOps room. And we have integrations turned on that GitHub reports to that room. So you basically, Manny will work on something and say, hey, here's a PR. It shows up in Slack. Whatever, typically everybody reviews it, unless there's somebody really specific that should. And then you sign off on it. What's nice about Slack is it's all right there. You see the PR, you see all the comments, and then once two people have signed off on it, they just merge it in.
Yeah. And we use GitHub for visibility. So we either use the GitHub checkboxes, or we actually just have people comment, looks good to me, just anything to say they've seen it and they approve. And really, if it's your pull request, you're responsible to go find people to approve it. If you're not out there championing for your pull request, then what's the point?
The other question I had was, you guys mentioned Rackspace a couple times.
Yes.
What's the use of that? Are you guys gonna do balancing across Amazon and Rackspace, or is it just kind of for fun?
Well, we've been in Rackspace for years. We're only moving away from Rackspace to get more integration with other Adobe teams. But really, it's our main products in Rackspace. We are moving, I guess, the center part of it out of Rackspace. There's still some things that we're really tied to. We really like physical machines, so it's hard to give up that in certain aspects. Those will probably move in time. But that's really why we're in Rackspace. We have a good relationship still. We have some physical architecture we want to keep, and we'll see where that goes in the future.
Hi, I'm from Snapfish. I have a question regarding workflow orchestration. As you mentioned, you are using a Jenkins to commit the cookbook or just to run your test?
So Jenkins, so when you do the code, you're going to push, as a developer, you push on a branch to GitHub. Jenkins, the tool Mergitron we have, Mergitron picks it up, it kicks the job to Jenkins and says, take these two branches, merge it, see what happens, and run the test on it. If the test passes, Jenkins is the one that will do the knife cookbook upload to the chef server. So that's how we kind of keep the, I guess I could technically do a cookbook upload on my own, but it kind of keeps us all in check that only cookbooks that have passed the test will get to that chef server.
So the job in the Jenkins, it's trigger after I approve the pull request, or it will happen before that? As soon as the developer submit the request for the pull request, so the job in the Jenkins, it starts automatically?
Yeah, so we have GitHub webhooks. So once Mergitron will run one set of tests on it, it will then, in the GitHub pull request, show the green or red that it passed. If it's green, then somebody has to still go through and merge that. We saw it's a manual step to merge master. Jenkins will then pick up the master change, rerun all the tests again just to make sure, and then once the master test passes, it'll push it up. So it's a two-step, three-step process.
So this workflow orchestration only for uploading cookbook, or you have a workflow for uploading your roles, uploading notes, attributes, everything?
All of it. It depends on which one it is. So we, from a Git standpoint, every cookbook is a repo, roles is a repo, environments is a repo, nodes are a repo.
And data bags.
And data bags, yes.
So you can't make any change to any part of our infrastructure without a pull request. You have to tell everybody about what you want to do.
Obviously, with a node or a role, there isn't much of a test to do. It's just, it does it. But yeah, each one of those aspects is managed by Jenkins.
Yeah, we rely a lot on human visibility. We want to share and show each other, hey, we're doing this, FYI.
I have two questions. First, why not the Rackspace cloud versus the AWS cloud? And then my second question is, how do you guys manage cleaning up old cookbooks? So after you've rolled one through dev test prod, and then now you have 30 versions of an old cookbook on your chef server. So we ran into this multiple times. I've spent weeks on this. So Rackspace Cloud, we do use it. We use it a lot. We have, I don't know, my coworkers, hundreds of servers in Rackspace Cloud right now. We also have OpenStack running at Rackspace, so we're doing that on our own. The reason we're moving to Amazon is really to team up with Adobe and use, there are other teams doing awesome stuff inside of Adobe to just private endpoints, things that we can take advantage of. So that's really why we're moving to AWS, is to team up with them and work close with them. So with cookbook versions, we started locking environments because of issues with cookbook versions. This gives us the freedom to kind of upload more and not worry about it as much. We can auto bump and just push, and the environments define what's actually running. So it just closes the scope a little bit, and the Chef dep solver runs way faster just by closing that scope. We then go in and kind of manually clean up every once in a while. When there's stuff that's really old, we'll go and just do a reckoning and clean it off the server.
I've got an organizational question for you guys. So where do you sit compared to the rest of IT in Adobe? And how far back? I mean, I know parts of Adobe are kind of the back office and manage legacy systems.
You got this.
Some are behind the cloud. Help me.
So as part of my role, I end up interacting with a lot of the rest of corporate Adobe. We sit between 3,000 and 12,000 miles away from them. Literally, we're in New York. Adobe is really centralized in San Jose, San Francisco, and India. We're the largest engineering team on the East Coast. So literally, our network tech is in Boston, and our desktop support is 50 blocks away. So all of that stuff literally it's email and service desk tickets. So we are really kind of segmented away from them. It is very challenging though to deal with that, because it's, if you have networking things, your network tech has to come from Boston and then coordinate with a team in India to do a change. I think we have 4 minutes left. If anybody other questions, if not, we will have office hours downstairs in a few minutes.
Hopefully it's a quick question. How are you doing package updates across your fleet?
That's an easy one, actually. So do you mean as in like a public package, or like?
Well, so you said you need to control all the things, so you have your own repository. Yep. So how are you managing updates? Like, say there's an OpenSSL bug, you need to roll out a fix really quickly. How are you managing that?
That never happens. So the package itself, we have the 4 repo mirrors, and they constantly pull. They do an rsync every hour, so it pulls from US kernel mirror for those, and then from that standpoint, they all pull from each other. So that comes automatically, and it's just a matter of change the attribute on the chef server and pull it in.
And also, we build our own RPMs. Everything's in CentOS, so we just find an RPM source or find a decent spec file and then build our own RPMs from that.
Cool. All right. Any other questions? Oh, one more in the back, and that's probably going to be the last one, because I think we're being called.
Just a real quick one.
Sure.
Are you guys open sourcing Mergitron?
It is, actually. So it's Snap Interactive is the original GitHub repo, and we have our fork of it. So you can check out ours. I think it's just Behance on GitHub, or Snap Interactive has it as well.
Hey guys.
Hi.
So I actually work at Chef, and I teach Chef. And one of the things I tell all of my students is that this is the only time in your life you will ever use Knife Cookbook Upload. And people just get terrified. They're like, what? You're going to build a workflow, you're going to put Jenkins or whatever form of automation, and a lot of people are terrified. So I was curious, in your environment, how long did it actually, from the organizational point of view, took to convince developers and people to actually give up that Knife Cookbook Upload to Jenkins?
There wasn't a lot of discussion, in reality. It was mainly just like the QE and ops team and maybe a couple developers that got in on it. But for the most part, it was like, well, you're not giving up to Jenkins. Stop. Just don't upload anymore. And we actually have multiple Chef servers, so there are a couple that we still manually upload to. But for the most part, we just said, Jenkins is doing it. We have tests. Something automated is going to approve of your work and let it happen. So it was fairly quick. It was more, the process of getting there was longer than the process of convincing people.
Yeah. We have a couple more minutes. Are there any other questions? Wonderful. Please join me in thanking Manny and Chris. That was awesome.
Thank you. Thank you all.
Thank you, everybody.